Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. Is electronic power steering, testing and repair. So electronic power steering is being used an awful lot more than it ever used to. It's actually been around quite a while. I mean, really started seeing it come into play around the 90s, but even before that, there were some forays into that, so to say. Um, but nowadays, especially with the lane keep assist and all that sort of thing, where the car almost steers its well, it does really steer itself to a point. Um, with all that technology now, we need electronic power steering. Otherwise, we wouldn't be able to do that, right? So the steering systems, there's not a lot of parts necessarily per se, and actually the rack is very similar to, um, just very similar to uh, a regular rack, and in some cars it actually uses just a regular manual rack with power added to it. Um, so some benefits is we can do an electric. Actually, let me get to that in a second. An electric pump, but steering angle sensors. Vehicle needs to know how far the wheels are turning and how far the steering wheel is turning. Torque effort sensor, how much effort the driver is putting in. Are they steering quickly or are they steering slowly? Sometimes there's even feedback to that too, haptic feedback, where it feels like you're actually connected to the road when you really aren't. Yaw sensor, so the vehicle knows what angle it's at. There's also latitudinal and longitudinal acceleration sensors on some vehicles. Now, these electric steering systems can be electronic by using the pump. Like instead of having the pump run off the belt, it's just an electric pump that runs the pump, instead of a pulley. Or it can be an electric steering rack, or it can be an electric motor that runs the actual steering column. So we'll see a couple different varieties as we go through this. So really came to the mainstream, I guess, roundabout in the 90s, like I said, with the NSX was one of the first more mainstream vehicles to have it. Um, Fairly simple system, and they still use something kind of similar today, as a matter of fact, but um, it's got a little steering angle sensor on the top, so you know the input, and then the output is the motor, which then you can see there's a gear set there and a worm gear there, and that moves backwards and forwards on the wheels. Now, they did this kind of out of necessity, they say, anyways, because the NSX was a mid-engine vehicle, right? It had the engine behind the driver. So instead of having the pump run off the engine and run all the lines down underneath out front to the steering, they just put this in instead. It simplifies the whole assembly, no more hydraulic fluid or anything like that, which is one of the benefits that manufacturers are using it for now, amongst others. But save on weight, save on fuel because you're not trying to turn that pulley. Um, Save on complexity, I guess, because basically it's a rack with a motor on it, that moves the rack in and out. Now, we also have to have a lot more inputs nowadays and outputs. We're going to look at a list in a little while here on this F-150, but you can see it gets information from many of the modules on the vehicle. The power steering control module here, the whole gear set here. Motor and a position sensor for the motor too, not just the steering wheel position. It also needs to know where that motor is turning. So these need to be reset, right? Torque sensor, steering angle sensor need to be reset, relearned. Speaking of steering angle sensors, what it does is it translates rotational motion into electronic signals by spinning around and the voltage changes. It's keyed to the steering shaft, and if you look at this one, it's got a large key and a small key, so it really only goes one way. Often located near the steering wheel, but not always. Could be down the other end of the steering shaft. And we could have multiple steering sensors. Oftentimes, it is up with the clock spring for the airbag. So if you have an airbag problem, it could come into play with this too, just because of how they sit next to each other. Sometimes they're even bolted to each other. Um, so anytime you move the steering wheel or anything like that, you may have to recalibrate it. It has to be recalibrated after repairs, or the electronic steering isn't going to work right, among other things, traction control, lane departure, and all that. And then this one is a torque effort sensor. So this is actually down on the gear itself. I think this one was on a Acadia, if I'm not mistaken. But it's got the torque effort sensor down there, so you can see the shaft coming in from the top, and then it comes down here, and it's able to measure how hard the driver is steering. Torque effort used for that. So as I said, there's a couple different ways we can do this. So one of them is that electronics or electric steering rack. So you have your usual tie rod ends and input shaft with the torque sensor in there, and then this one has an electric motor on it with a little belt. So it spins one way, the rack goes one way. If it spins the other way, the rack goes the other way. It's got a threaded, like a pulley on the end. We'll see a better picture of that in a minute. So there's the electric motor, and you can see there's that housing for the belt. And then if I come in here, there's the belt. And then you can see the drive motor here. And then down here is the driven gear, so to say. And actually, you can get a better look at it over here. So as it turns, when it turns one way, it's threaded on the inside, so it moves the rack in or moves the rack out, side to side, just like a regular rack and pinion, just with an electric motor to make it happen instead of a hydraulic pump to make it happen. Some other vehicles also use this is called motor-driven power steering. So it's a little power pack up top of the steering shaft, so it's inside the vehicle, inside the firewall there. So there's where the steering wheel would be, and then the adjustments and stuff, and then there's the power pack, and then that drives down to basically a manual rack and pinion assembly. So it's what's old is new again, I guess you could say, right? So it's just using an old manual rack type situation with the driving the motor up top, and you can see the motors kind of separate, but they can't be serviced. None of these can be serviced. They have to be serviced as an assembly. You can't just like replace them a lot. You could, but they don't make service parts for them. So you'd have to track down a replacement if you need. And here's just a different picture of one of those where it's not a line drawing. So you can see there's where the steering wheel would go, and then it comes down a small shaft with a tilt and telescope assembly into a bearing. And then this is the drive motor that drives assistance. It assists based on how hard you're turning the wheel, right? Actually looks like that one's out of a Ford. It looks like a Ford key right there. So I guess Ford uses that. And then there's this one, which is out of a 2014 Infiniti Q50. So you can see it looks like it's got a power steering kind of type unit going on up there. It's kind of hard to see what's actually going on. I think that's actually a tilt and telescope function, because it has a power steering rack, but they wanted to make it so there was no direct connection from the steering wheel to the rack. Don't really know why. They ended up changing it back not that long later. But this piece right here, the number one is pointing at, and that's on the firewall, that is a clutch. So when under normal operation, it's just going to take the input of the driver, but it's not directly connected to the steering gear. That is its fail point. When it fails, it locks the clutch. And when the clutch locks, then I do have that direct connection down to the steering gear like that. So A lot of other manufacturers now, anyways, are totally disconnected. They just use a steering wheel or yoke or whatever. A lot of electric cars for sure. The Cybertruck is like that. And apparently, I learned in the last class that the Cybertruck has two motors to steer. So don't know why they decided to do that instead of having the single motor steering unit, but they do things how they do things. So it just kind of is what it is. Um, so this, uh, so a lot of cars now, especially like EVs, because EVs use electric power steering because what are you going to turn the pump with? Because there is no motor, right? So everything's powered by electricity. All right, let's go live here and we'll look at a couple different things, couple different scenarios with different vehicles. So the first one I want to pull up is the Ford. So Ford does it in this way. Actually, let me go into get through here and then we'll go over here. So let's look it up in repair information first. So this is a very common repair on some of these, 159 times uh, so far seen. There's TSBs on it too. Recall for the electronic power steering assist steering gear. Yep. So that was on Mustangs, F-150s, Expeditions, and Navigators. Oh yeah, this was a funny one. So some affected vehicles are repaired with service replacement electronic power assist steering gear and may have the secondary digital torque sensor in the steering gear calibrated with an inverted polarity. So they basically put it in backwards. If the primary steering torque sensor experiences a failure or fault, the inverted polarity of the second sensor may cause the steering wheel to begin oscillating without warning, alternating clockwise and counterclockwise. That sounds exciting. When attempting to steer due to the EPAS providing unintended steering assist. Your dealership may have either A, installed the affected steering gear on a vehicle, or B, sold over the counter a suspect replacement gear. So this was two dealers, and then what they have to do is they have to recall those particular vehicles and get them back in and fix it. That was kind of interesting. Let's see. Uh, remove and replace. We'll see that this is the one like the belt with the little belt on it. So we get to where it's open, right about there. So you can see the motor there, and you can see the rack is here. So you can see the boots, the bellows boots there. So the rack is there, and the motor is there. You can see where the belt would be right there in their computer drawing of the underside of the vehicle. There's a little bit better view of it. And it actually has the connectors and stuff on there as well. And then once you're done installing it, we need to come down here. And when installing a new steering gear, it must be configured using vehicle as-built data or module configuration information retrieved earlier in this procedure. So that is a PMI process. So programmable module installation, you leave the old rack in there to start, copy the information off it, copies it on the scan tool. Then you would install the new one, and then scan tool go back in. You're going to go to the same procedure, and you're going to basically select that file you copied and paste it back into the new steering gear, and then everything should work properly. Plus, you got to recalibrate the steering angle sensor and all that. Let's go here quick too. Oops, this isn't there. So here's a list of all the inputs that it needs from different modules for steering. So we have accelerator pedal position sensor, whether or not the ABS is active, RPM, ignition status, lane keeping alert, because it works with the lane keep assist system, power pack status, power system status, stability control, whether it's active or not, steering angle request, steering effort request. It's going to inform the power steering control module of the current driver selected steering mode, normal, sport, or comfort. Traction control, trailer backup assist requests. So that's for the trailer backup assist. So you got to know which way the vehicle's steering for a trailer. Let's see. Transfer case range, transmission gear, vehicle lateral and longitudinal acceleration, and yaw rate. So those are all different sensors that are necessary for steering assist calculations. Vehicle speed is going to be used to determine the level of assist applied to the steering gear and to validate the steering wheel component angle by comparing the rotational speeds of each wheel. Difference in speed of each wheel is used to derive a steering angle for comparison against the motor position sensor. So there you go. That's how it checks itself with the steering, the wheel speeds. Okay, we'll go into scanner, and we'll come down here to power steering control module. And we have codes and data, functional tests, special function. We have a couple different things for resetting different errors. And then there's that PMI right there, the programmable module installation. So it's going to either read data or write data. You just need to pick which one you're doing. And then you would go through that. Okay. And then also remember that with the ABS, sometimes, let's see, calibrate longitudinal acceleration sensor. And that one's in there. And the yaw sensor, sometimes in the airbag. So that one doesn't have it, but just remember there's a couple different things you need to do. And then also remember this image processing module A for the lane assist. Well, that's for my lane keep detection. So I might need to go in and do a reset on that too. So lane departure warning system camera alignment, possibly on that. Okay, let's go to that Infiniti. And we'll just pull up the steering. All right, so this one has a fair number of TSBs on it because I think they had some problems with this recall. Direct adaptive steering, reprogram and recalibrate. So you have to change the calibration on 3 modules. And then it's just going to walk you through how to do it using their factory tool. But you got to go in and you got to the different part numbers. So that'd be their calibration ID. So you need to update it if it's not one of those. And then you would just go through. You'd have to do this with like a J-box or the factory tool if you have the factory tool because it is a flash. And then calibration and so on. So let's see. We remove and replace. Direct adaptive steering. All right, so it's kind of hard to see. They don't really do a good job of showing the picture of what that whole assembly looks like. If I do the column. Yeah, so that's the example of what the whole assembly looks like there. Direct adaptive steering. And there's the upper shaft, which goes into the clutch. Somewhere in here. Yeah, not the best pictures of this stuff. Tilt and telescope. And that's speed sensitive steering, so it's different. Yeah, so there's that clutch. It's really hard to, they don't really give you that good of a picture of the clutch. But let's look at the power steering pump. I think this, if I recall, this was an electric pump. Oh, that's a regular belt-driven pump. Okay, never mind. But they just tried to get the get it disconnected for some reason. I don't know why they would need to do that. I don't think, but a lot of them replaced, and then it was, or it costs. Let's see, $1,900. It looks like, yeah, $1,900. for that. For the rack. And oh, let's go back to that Ford for a second. I forgot to do this. There. And the Ford is about $1,400 as well. Now, let's go into the BMW. That's going to have a few things in here as well. Electromechanical power steering. 5 different variants. And there's a steering startup test. What that does is a teach-in software end stops. The service function is needed after the following events. If this fault code was found, adjusting procedure and repair measures of the front axle, depending on the internal system status, transfer to corresponding startup routine takes place automatically. Steering is mounted completely in the vehicle. All connectors inserted. Vehicle is on a level surface. Alternatively, the vehicle is raised slightly on the hoist. Steering wheel movement of the front wheels must not be restricted by obstacles. Combustion engine must be running. Must be no faults. And there must be no internal faults in the instrument cluster either. Software end stops at electromechanical power steering are correctly taught in at this time. No further measures must be performed. Another teach-in process only makes sense if one or more of the following repair works were performed. Adjusting procedure repairs on the front axle, especially track rods. Steering box was removed and then reinstalled. Now steering replacement. So steering box was removed and installed. So if I even had to take it out for a procedure, I have to do this function for the end stops. And then, yes, you can do that, or no, you don't need to do that. And then you can just go on and you're done. So that one's fairly straightforward, at least. And then that one's also going to have, I believe that one's also in the brakes. Adjustment. No. It's to adapt the brakes to the hydraulics. And we'll see how long this takes. Okay. Done. And if we look it up in Shopkey, that looks awfully a lot like the Ford one with the belt and all. And what was the Ford one? About $1,500. So I don't know who they buy it from, but BMW is $4,500. So guess it's the BMW tax probably on that, right? Go back here. And after we're done, we need to do the soft stops, right? Yep. Turning steering wheel in both directions, limit position, airbag indicator must not light up in the process, and then teach in the end stop in the software. So that'll be that. And gets that done. Now there's TSBs on that one too. Steering gear movement not smooth. And the only way to fix this one is a flash. So they reflash the vehicle and fixes the problem. So kind of an interesting one. All right. All right. So that is electronic power steering. Hopefully you picked up a couple little tips and tricks there. Just remember, the biggest thing is you just got to make sure you reset all those sensors that need to be reset after the fact. Because if you change the steering gear, the properties of that will be different. The cameras and the power units and all that stuff, it's all, it all needs to be reset, relearned, that sort of thing. So just be aware of that. Otherwise, it should actually be maybe less complicated to work on because there's no hydraulics involved, right? So. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week, and we'll see you on any of our other videos. Have a good week, have a good night, and take care.